Hi all, this is Surya, working in Dr.SNS Rajalakshmi College of Arts and Science, Department of Computer Science Full Stack Web Development. And today we are going to see about operating system Semaphores. Semaphores, the robust alternative to simple mutual exclusion is to use semaphore, which are integer variable for which only two automatic operations are defined. The first wait and signal operation is shown as given here. There is a non-automatic return macro code and protected by the hardware lock, that is 14 watts and S greater than or less than 0, S minus 1, signal S plus 1. Here the format wait mutual exclusion mutex into 1. Critical section signal reminder. Note that not only the variable steps S plus plus in the invisible necessary wait operation when the test provides false, where there is no interruption before S gets decremented. It is okay. However, the busy loop to the interrupt when the test is true, which even the system from hanging forever 15. And here the properties 1. Simple, works with many process, can have many different critical section with different semaphores. Each critical section has unique access semaphores, can permit multiple process into critical section at once if desirable. Type semaphores. There are mainly two types, binary and counting. Binary, it is a semaphores used to implement mutual exclusion, often called mutex. Binary semaphores is initializes and 1 and the only take value 0, 1, 1 during the execution of the program. Counting semaphores, they are used implement bounded concurrency. Semaphores can be used for force synchronization if the preceding process does a signal at the end and the follower wait at the beginning. For example, here we want P1 to execute before P2, the statement P1 and P2 and the statement 1 and 2 to prevent the looping, and the structure type defines structure, int value structure, process, and int PTBL waiting S semaphore. It is critical that these be automatic in uniprocess. We can disable interrupts, but the multiprocessing other mechanism for automatically are needed. Semaphores wait S value minus 1, that is equal to S greater than or equal to 0. Add this process S and L block semaphore signal value 1 plus 1. And here the deadlocks. One important problem that can arise using the semaphore to block the process waiting for a limit resources problem deadlock, which occurs multiple processes are blocked waiting for freed one blocked process, illustrated with the example starvation. Another problem to consider that the starvation in which one or more processes get blocked forever to get the chance their turn the critical session. For example, in the semaphores above, we did not specify the algorithm for adding process to the waiting query in the semaphore. In wait call or selecting one to remove from the queue in the signal call. If the method chosen is a FIFO queue, then every process will be eventually get their turn. But LIFO, first in first out, last in first out, queue is implemented instead of first process to start waiting could starve. The bounded buffer problem. This is generalization of the product consumer problem where the access is controlled to share group of buffers of limited size. In the solution, two counting semaphore full and empty keep the current number full and empty and initialize 0 and n respectively. The binary semaphores mutex control access to critical one thinker produce the full buffer and consumer producing empty buffer. Reader-writer problem. The reader-writer problem, the same producer-consumer problems. We have only one, many concurrently readers, one exclusive writer. Locks. Two possible, that is guidelines can be used. No reader is kept unless the writer holds lock. If the writer is waiting for the access, no new reader gains access. Note, starvation can occur either the rules followed rigorously. The reader's writer's problem. Reader do wait mutex, one reader lockers write, readers perform, read count 0 to 1, and the last reader free writers, writer do wait, writing is performed, signal that is true, and the problem semaphores is 1. Thank you all.